So this is the third slide, I think, the third slide of where we left off yesterday. Same exact lesson. We're still talking about multiplying and dividing rational expressions, meaning fractions, but these have variables in them. So let's start with A. The directions for this page say factor the numerators, factor the denominators completely, cancel out any common factors. So what we're going to do here is we are multiplying these two things. Now, we could just multiply straight across the top, and you could multiply straight across the bottom. But I'm just telling you right now, you make your life so much harder when you do that because you get much bigger numbers and much bigger things to deal with. Instead, what else could I do? How could I simplify here? Because I've got two things I'm multiplying, and actually it's very easy when I'm multiplying two things to start making things smaller. What about it? Okay, so we're going to cross-cancel some things. Notice that let's start with, just like Joe said here, we're going to take a look at this and this. And we're going to cross-cancel anything that has in common. So let's look at the 2 and the 8. What is something that goes into both 2 and 8? 4 goes into 2 and 8? The weirdest part was you both said it at the same time. Like, it wasn't even like somebody said it first and they were like, yeah, it's 4. They were like at the same time it was 4. That was awesome. Okay, 2 goes both into 2 and 8. So we've got 2 goes into 2 once, 2 goes into 8 4 times. The x's, what goes into both x to the third power and x to the fourth power? Okay, so x to the third power goes in here, leaving just one x left over. X to the third power goes in here, leaving just 1. It's x to the 0 power, which becomes 1. So I just like to write it all out. Like, does the 1 actually matter? No, as long as it's being multiplied, because it becomes the same thing. However, I like to show all that work. Then we've got y to the third power and y to the second power. What do they have in common? Okay, y to the second goes into y to the third, leaving just y. And y to the second goes into y to the second, leaving just 1. What about the other two? Do they have anything that cross cancels? Okay, so 3 goes into 3, 3 goes into 3 once, 3 goes into 15 5 times. What else? X squared goes into x squared. Yep, just leaving a 1. So here's what we've got. Just so you can see what we've got. On the top on the left, we've got 1xy. On the bottom, we've got 1 times 1.
So this is cross multiplication?
We're just cross-canceling right now. Before we do the multiplication, we're trying to make things much smaller because we can make our lives a lot easier. So we've got xy over 1 times 5 over 4. Which becomes what? Bless you.
It should be 5xy and then 4.
5xy over 4. That's it. Now, it did say in the directions here, determine where the expression is undefined. This is the first part of the answer. That's that circle part that I always do. And in just a moment, we'll figure out where is it undefined. Okay, so the things that we're going to need to know is what is it that x, bless you, cannot equal, and what is it that y cannot equal. So let's look on the left. Yeah, so let's look at that one on the left. On the left we had 3x squared. If we set that equal to 0, that'll show us what it cannot equal. So we'll divide both sides by 3, and we get x squared is equal to 0, or x is equal to 0. So we know that x cannot equal 0. That's one of the things. Well, what would happen if x equals 0 over here? It would end up as 0, so it can't equal 0 over there either. So 0 works in both places. 0 is the number in both places. But what about y? We've got 8 times x to the third times y squared. If any one of those three factors equals 0, then the whole thing is going to equal 0. So let's just figure out y squared equals 0. What is it that y is not allowed to equal? 0. So x cannot equal 0 and y cannot equal 0. So I'm just going to put that right here next to my answer. X cannot equal 0, y cannot equal 0. Both of those things have to be listed because x and y are both factors there. Yes, ma'am?
Can you solve for x1 ones you don't have to resolve for it, right?
Well, it might be it might be true that on the left the x might have been like, let's say that on the left it had 3x squared and on the right it had x minus 1. In this case, in either case, their x is going to be 0, right? We would have x cubed is equal to 0 or x squared is equal to 0. Either way, that's going to equal 0. But you should check it on both sides because those... Yes, ma'am?
I don't understand that about the canceling. Like, how did you get, like, how do you know x cannot equal 0? Where did you get the 0?
Because the denominator is not allowed to equal 0. Remember that when we said that this is the things that it cannot equal, we're not allowed to have zeros in the denominator.
Or we don't.
Well, we don't have anything. We don't have anything for x and y. X and y could be like any possible numbers. Like, we can plug in whatever we want. But if we plug in 0, then this will not work. It's broken. You know what I mean? It's like if you've ever got if you've got something like maybe like as a kid you had a toy and it was like taped together and it's like, as long as you don't do this, it'll be fine. As long as you don't put in a 0 here, it's okay. This will work. If you plug in a 0 for x, then we can't solve this. And if we plug in for y with a 0, then we can't solve this. We can get to this answer right here as long as x does not equal 0 or y does not equal 0. That's what they're saying there. Plug in whatever you want, but x cannot equal 0 and y cannot equal 0. Let's keep moving. We got a lot to do here. So this one does have some things that can be factored. So if there's any factoring that we can do, we should do that right away. So take a look. There's 4 things, right? Top, bottom on both sides. So anything that you notice that you might be able to do, even if you're not sure where it's going to take us.
The 3 out of 3x plus 1.
Okay, so there's an x plus 2 on top, and she's saying factor out a 3 on the bottom. If I factored out a 3, what would I have left inside?
X plus 4.
X plus 4. Okay, anything I can do on the right-hand side?
X plus 2x minus 1. On the left.
Okay, that bottom there is the difference of 2 squares, which means it's going to end up as x plus 2, x minus 2. Why did that help me? Good. This x plus 4 is going to cancel with this x plus 4. Anything else going to cancel? X plus 2, x plus 2. Leaving only, I'm about to do this completely wrong, catch me when I do it, 3x minus 2. Yeah, it's in the denominator. And actually, we could leave it like that, and another possible answer you could do is you can just write that out if you want. 3 times x is 3x. 3 times negative 2 is minus 6. Either one of these are perfectly acceptable here. I prefer the second one because there's still math to do. There's still math to do, so I say work out the math. You'll get full credit that way. Now, we did not figure out what x is not allowed to equal. So let's come back here to the factored version. There are 3 things in the denominators. They are here. 1 of them, 2 of them, 3 things. Because that 3 is never going to equal 0, right? I could say 3 equals 0. That's never going to happen. 3 will never equal 0. However, x plus 4 could equal 0. That's a possibility. So we'll subtract 4 and subtract 4, and we get x is equal to negative 4. We are not allowed to have x equals negative 4, because that will make the denominator 0. That's a problem. Right? Look directly above. If you plugged in negative 4, you would get negative 4 plus 4 is 0. And 3 times 0 is 0. We're undefined. We can't go any further than that. Right there, there's nothing we can do. So that's this one. Then we've got x plus 2 is equal to 0, which is going to give us x equals negative 2, which we're not allowed to have. That's the blue one. And then finally, x,
These are all your answers, right?
this is all part of the answer, yes. So x is equal to 2. We're not allowed to have that either. So our answer looks like this. Our answer is right here, but x is not allowed to equal negative 4, and x is not allowed to equal plus or minus 2. You could separate those. You don't have to write them together. I was just combining them into one answer there, make less work for myself. You could have written x cannot equal 2, x cannot equal negative 2. Yes, sir?
So if something's like outside of the parentheses, multiplying, you don't have to do like the have to equal to 0?
So he's saying, why did I not equal that to 0? Because there's no situation where 3 will ever equal 0. Never.
Okay.
The others are variables. They could equal 0. So the answer to your question is the reason that I didn't put the 3 equal to 0 because 3 will never equal 0. If that had been an x on the outside, I would have said it equal to 0. But 3 is never going to equal 0. If you've got $3, if you've got $3 in your pocket and somebody says you've got $0 in your pocket, that doesn't make any sense. You've got $3. But if I say I have X dollars in my pocket and you say, and I say, is it a possibility that I have $0 in my pocket? Well, yeah, there's a lot of things that X could be. Okay, so 3 things we're multiplying. Now my recommendation is pick 2 of them. You could, again, you can multiply straight across the top and straight across the bottom if you want. You're going to get big numbers. You are going to do way more work than everybody else is going to do. So if you're like, man, I stink at cross canceling, sure. Could you do it the other way? Yes, and it's just going to be longer for you in the long run. But I'm going to look at this and I'm going to just look at the first 2. I'm going to only look at the first 2 and I'm just going to cross cancel those. So what I'm doing right now is just looking at those first 2 terms. And I'm looking for anything that cross cancels. Do I have anything that cross cancels on the first 2 terms? Okay, so they both have an x, right? This x goes into x once, x goes into x once. That's just going to leave a 1 and a 1.
So it's going to be 2 and then 1. And then,
Yeah. Okay, so there's nothing else there, right? So there's nothing else I can do there. Let's look at the last 2. Like maybe now I can look at these 2. So I've got a 2 and a 20 and an x to the 7 and an x to the 4th power. I'm looking at just the second terms now. Anything cross cancel on those? Okay, 2 goes into 2 once, 2 goes into 20 10 times. What about the x's? X to the 4th goes into here once, x to the 4th goes into here and leaves x to the 3rd power left over. Now, do you notice between any of the things left over, here's what we've got left over, 1 over 15, we've got x to the 3rd over 1, and we've got 10 over 1. Are there any 2 of those fractions that could still cross cancel?
Yes.
Which ones?
15.
The first and the last, we could do this and this would cross cancel. What goes into both 15 and 10? 5 goes into 15 3 times. 5 goes in here twice. Now it's great. Like now all I've got is 1 over 3 times x to the 3rd over 1 times 2 over 1. These are way easier to work with than what I started with. What is the whole top going to multiply? What is that going to become? 2x to the 3rd. What's the bottom going to become? 3. So here is my answer. But I still need to look for what x cannot equal. So I'm going to go back to the beginning here. So notice 15 is never going to equal 0. I don't need to set that equal to 0. It'll never equal 0. That will always just be a 15. But this 2x, it is possible that a 2x could equal 0. Divide by 2, and we get x cannot equal 0. That's for that middle term. For the third term, x to the 4th equals 0. What times itself 4 times will give me 0? 0. So x cannot equal 0. Again, it's just x cannot equal 0. That's the only one we came up with. X cannot equal 0. That's the only thing x is not allowed to equal.
So let's say that this was some problem was on test. You would answer with x is not equal to 0 and 2x third.
Yep. So, because it answers 2 parts here. The first part asked us here to factor completely. That's in the circle is factored completely. The second part of the question says determine where the expression is undefined. That's where the box is. That's where it's undefined. X cannot equal 0.
So why do we have to do the denominator first?
Because that's the only way you could find out where x, without the denominators, you couldn't have found out what x cannot equal. That's how we that's where we got this from, is from the denominators. We did, look, denominator, we did that right here. Denominator, we did that right here. The only reason we knew that x could not equal 0 is because of the denominators. I wouldn't. Just tell. I mean, like, because that's not going to get you any points for, like, how you did your work. So these are nice and easy in the beginning. A lot of times people are like, well, I can just tell it's 0. I go, okay, but we're at the beginning of this. When these get really complicated, for example, let me give you a fraction. What is it that x cannot equal there? You see what I mean? It's not as easy as just telling sometimes. We have to go, oh, I have to do some stuff to figure out what x cannot equal there. That takes some work. You won't have a problem doing that soon. It's just let's start off easy. You know what I mean? Let's start off with like working with numbers in a nice controlled environment where everything's nice and happy, and then we'll get to Ugleysville. All right, again, it says factor completely here. Before I start trying to like cross cancel, I cannot cross cancel much here because what I've got here are not things being multiplied. So I can't say like, oh, an x and an x, but there is some stuff I can do to factor completely here. What could I do?
At the top, you can take out 10.
Okay, so the top left, we're going to factor out a 10. What would be left inside?
X minus 4.
X minus 4. Okay, anything that we can do on the bottom?
Yeah. X minus 4, X minus 2.
Because two numbers that multiply to give me 8 that also add to give me negative 6 are negative 4 and negative 2. That x plus 3, I doubt we can do anything with that. But what about the 5x plus 15?
You can take out 5 and you're left with X plus 3.
Okay, what things am I going to cancel?
X plus 3 and X plus 3 and X minus 4.
Okay, so tops can cancel with bottoms and bottoms can cancel with tops. So that's what we're doing here. Here is an x plus 3 on top, canceling with an x plus 3 on bottom. Here's an x minus 4 on top, canceling with an x minus 4 on bottom. What do I have? Is there anything else actually that cancels? The 10 and the 5. 5 goes into 5 once. 5 goes into 10 twice, leaving me with what when it's all said and done?
2 and x minus 2.
So that is the simplified version of all that. It broke down way simple after canceling all of that out, but you got to know how to factor it. That's the first thing, is how do I factor it? Secondly, we got to figure out what x is not allowed to be. So we're going to go back to the factored form here. There's 1, 2, 3 things that it cannot be. So here is x minus 4 cannot equal 0. So that's going to be x equals 4. We're not allowed that. X minus 2 equals 0. We're not allowed that. So that becomes x cannot equal 2. X plus 3. We're not allowed that. So we get 3 things that x is not allowed. And here's where they came from. There's the red highlighted one, the blue highlighted one, and the green highlighted one. That's where they all came from. They came from the denominators. So on to my answer, what I'm going to add is, excuse me, here is the factored version. What x is not allowed to be is x cannot equal 4, x cannot equal 2, and x cannot equal negative 3. All right, next up on the next page, we get to dividing. Now, dividing, these are fractions. Do you remember when we divided fractions? First of all, just so before we start, so this doesn't get confusing later. If I had 1/2 divided by 3/4, how would I go about doing that? Keep, change, flip. Keep the first one the same, change the division to multiplication, and flip the second one. In which case, 2 goes into there once, 2 goes into here twice. This would end up as 2/3. So I'm going to use that same strategy here in a minute when things are a little more complicated. I'm still going to be doing fractions, and I'm still going to be keep changing and flipping. So let's start by rewriting. First of all, we've got 2 fractions that we're dividing. So we're going to go, we're going to keep the first one the same, 4x to the 3rd power over 9x squared y. I'm going to change that division to multiplication, and I'm going to flip the last one, 9y to the 5th over 16. Okay, so now we're back to where we were earlier, like just on the previous one there, is now we can start seeing if anything cross cancels, if anything is going to simplify for us. So let's work this out now. It also says determine where the expression is undefined. So what can I do?
Cancel out the 9.
Okay, so these 9s are going to cancel out. 9 goes into 9 once, 9 goes into 9 once.
And the y.
And what?
And the y.
And the y. Y goes into y once. Y goes into y to the 5th time, y to the 5th power, leaving y to the 4th.
And then you do 4 and 16.
4 goes into 4 once. 4 goes into 16 4 times. I'm just going to rewrite now because it's getting a little bit crazy looking. So I'm just going to rewrite. We can still do more cross canceling. It's just getting to be a lot. So I'm just going to rewrite here so we know what we're looking at. Anything else we can do? Yes, ma'am. No, because then you're going to be canceling different things. You're going to be canceling because one of them is flipped, we can cross cancel when we multiply. When we divide, we can't do it the same way because we'd be canceling top with top. Like if you imagine we just flipped one of the fractions upside down and that's what allows us to do it there. Is because when you're multiplying, you can do this. Yes, ma'am.
Why was there 1 help 4?
Because 4 went into 4 one time. When we cross canceled that 4 and 16, 4 went into 4 once, 4 went into 16 4 times. That's why the 16 has a 4 next to it, and the 4 has a 1 next to it. Okay, anything else that we can cross cancel here, or just cancel it all? Okay, so, excuse me. X squared goes into x squared once. X squared goes into x to the 3rd power, leaving just x on top. I don't think I see anything else that cancels out, so what do I have left over? Okay, so when we are determining what it is that y is not allowed to be, I'm going to go back to our multiplication problem. Remember, we kept going to the multiplication. I'm not going to go all the way back to the top. I'm going to go to my multiplication problem here. So what we've got, because remember that 9y to the 5th is going to end up being flipped upside down. So if you look up here and you're like, oh, well, isn't this in the denominator? Not really, because it's about to be flipped over. So what we're looking at here is x squared is not allowed to equal 0. So that would be x equals 0. That's not allowed. And y is not allowed to equal 0. That's coming from right here in the denominator. So we've got this simplified. X is not allowed to equal 0. Y is not allowed to equal 0. Yes, ma'am.
Where did you get the y doesn't equal 0?
So this right here and this right there. I just said y is equal to 0 and there was nothing more to do to it, so I just said y is not allowed to equal 0. There's no more math to do there. If you want, the step right before that would have been this. Why?
X equals 0, where did you get that?
Here. When we take the square root of both sides. All right, moving on to B. Okay, probably going to be some factoring going on here. There's probably something going on, right? There's a lot of big things here, and it's not just things being multiplied. So let's see what we can do. Let's start top left. Let's go in order. X to the 5th minus 4x to the 3rd. Anything we can do with that? X to the what? Good. X to the 3rd. Actually, what I'm going to start by doing is rewriting this. I'm just going to rewrite this as multiplication first, just to make our life a little easier. And then I'll do exactly what you just said. Minus x minus 2 times x squared minus 1. Okay, so all I did was rewrite. I keep, change, flip. That's all I did right there. So as we said, that top term on the left there, we're going to pull out an x to the 3rd power. What will be left inside? What?
No, wait, not X, I'm sorry.
-4.
Okay. How about, what's wrong? Some of you have phones out. They're about to become my phones. Are we okay with that?
Yeah,
Okay.
I'm just looking at the.
Okay, something interesting about the top there I notice. About what we just did. We didn't do anything wrong, but look where we ended up. I feel like there's still something to do there.
Divide.
That's the difference of two squares. So what is this going to end up as right here?
X plus 2x minus 2.
So that whole numerator is going to end up as x to the third, x plus 2, x minus 2. What about the denominator? Yes, ma'am.
Why is 1 plus and 1?
Because that's how we do difference of two squares. How about the denominator? X squared minus x minus 2. Can we factor that? X minus 2. X plus 1. Okay, that's factored. X squared minus 1. Anything I can do with that? Difference of two squares. X plus 1, x minus 1, again, difference of two squares. Okay. What about the bottom right? What can I do with that? Pull out x to the third. What's left over inside?
Sorry.
X squared.
X squared.
Just minus X. And then -2.
I've seen that somewhere before. Where have I seen that in parentheses?
Right
Right
above.
here. That means
To the
cancel
left.
out.
Right here, which means that that's going to break down into what? We already broke that down. It's going to break down into x minus 2 and x plus 1. Now, I've got to clean this up because this has gotten kind of messy. So here's what we've got so far. Here is our numerator. Oh, that's not a highlighter. Here is our numerator over here and our denominator over here. Our numerator over here and our denominator over here is actually this one right there that is all the way broken down. So I'm just going to rewrite before we start canceling anything. X to the third times x plus 2 times x minus 2 over x minus 2, x plus 1 times x plus 1, x minus 1 over x to the third power, x minus 2, x plus 1. Whew, that was a lot. Are we done? No, not even close. But actually, we're in the easy part now. Why do I say that?
Because you can just cancel out.
A bunch of things are going to cancel out. Give me an example. What's something that cancels out? That's going to cancel out. What else?
X minus 2.
X minus 2 and x minus 2. You could have done the one on the left as well. Any top with any bottom is fine.
X plus 1 to bottom.
X plus 1, x plus 1. Okay, so we end up with x plus 2 times x plus 1 over x minus 2 times x... Oh, I'm sorry, I did the one on top wrong, didn't I? My apologies. I wrote plus 1 on top, and that should have been a minus 1. Minus 1 over x minus 2, x plus 1. Okay, so, all right, I was just checking over my work there. So it doesn't look like we could FOIL this out if we want, but I'll tell you why I'm not going to is because I want to take a look at like here where we have everything FOILed out, and I want to figure out what x is not allowed to equal to. So each one of these things I'm going to check. X minus 2 equals, not just 2, I'm sorry, x minus 2 equals 0. So x is not allowed to equal 2. That's one of them. But check it out. Right here, this x minus 2, there's another x minus 2 right there. I don't need to do that twice. Yeah, it's got a multiplicity of 2 if you want. It's the same thing. It's just got a multiplicity of 2. x plus 1 equals 0. That's going to end up as x equals negative 1. But we've got two plus 1s there and there. And then finally, we've got x to the third power equals 0. Well, what times itself 3 times will equal 0? 0. Here are the things that x is not allowed to equal: 2, negative 1, and 0. Yeah, sorry, let me put that with my top answer. Here is the simplified version. Then we get x cannot equal 2, x cannot equal negative 1, x cannot equal 0. Okay, let's move on to C. Actually, C is going to be a little bit easier, so don't worry. C is a little bit easier, D is a little bit tough, so it goes back and forth. All right, talk to me about what's my first step going to be. Keep, change, flip. So I'm just going to keep this the same, change it to multiplication, and flip the last fraction. Now what? What things can we cross cancel? Okay, x squared goes into x squared once. X squared goes into x to the fourth power, leaving x squared left over. Anything else? 4 goes into 4 once. 4 goes into 12 3 times. So here's where we're at. We've got 1 over 1 times 3y squared over x squared y. Anything else that can still cancel? The y's. There's a y on top and a y on bottom. Y goes into y, leaving 1 left over. Y goes into y squared, leaving just 1 y on top. So we get 1 over 1 times 3y over x squared, which becomes what? 3y over x squared. But I have to figure out where this is undefined. I'm sorry, my brain shut off there. So we've got x to the fourth is equal to 0. We have to figure out where that would equal 0. What would x be? 0. Right, because the number that times itself 4 times that equals 0 is 0. There's one of them. X cannot equal 0. What else am I going to write? Y equals 0. So it's just y cannot equal 0. There's no more math to be done there. So we've got x cannot equal 0 and y cannot equal 0. All right, one more. This is a big one, but hopefully we can factor it and get something good to happen here. We've got 2x squared minus 7x minus 4 over x squared minus 9. I'm going to keep change flip right now, get this out of the way. 8x squared minus 28x plus 12 all over 4x squared minus 1. We've done our keep, change, flip. We are good. All right. Let's talk about factoring the top left. Let's just go in order. I didn't what? You don't flip the first one. Keep. That's why it's called keep. Keep it the same. Okay, how do I factor 2x squared minus 7x minus 4? Multiply what? Okay, so we're multiplying the first thing times the last thing, and we get negative 8. So I'm looking at for two things that multiply to get negative 8 that add to give me what? Negative 7. So negative 8 and 1. So I'm going to take that, I'm just going to do that factoring over here for a second. 2x squared minus 7x minus 4. We're going to break that down into 2x squared. That 7x is going to become a negative 8x, a 1x minus 4. What am I going to do with that to keep factoring? Group them together. What do 2x squared and negative 8x have in common? 2x. What would be left inside?
X minus 4.
what can I factor out of x minus 4?
1.
A positive 1, which just leaves me x minus 4. So my two factors on top will be 2x plus 1 and x minus 4. Talk to me about the denominator up top. Difference of two squares, so it becomes x plus 3, x minus 3. Talk to me about top right. You could, but I see something first. What do they all have in common?
4.
They all have a 4 in common. Let's pull that 4 out to make our life easier. The whole reason for doing that is make our numbers smaller. What will be left inside after I pull out that 4? Okay, now we still have to factor that top part, right? So that this part right here, we still have to factor that. Okay, first times last in there. So we get 2 times 3 is 6. I need two numbers that multiply to give me 6 that when added will give me negative 7. Okay, so let's just do that work over here. We've got 2x squared minus 7x plus 3. And we're going to break that negative 6 down into a negative 1 and a negative 6x. Don't forget the x's that go on there. It's a common mistake, and then people have a misfactoring. All right. Let me just redo that a little bit because it doesn't look very clean. 2x squared. What do 2x squared and negative 1x have in common? What would be left over inside?
2 minus 1. 2 minus 1, sorry.
What about negative 6x plus 3?
Negative 3.
3?
Yeah.
Okay.
Negative 3.
Oh, negative 3, sorry. What would be left inside?
2x.
Minus 1. So, that numerator up there, boy, this is a lot to write. Here we go. So, on the left, we have 2x plus 1, x minus 4. On the bottom, we had x plus 3, x minus 3. On the top over here, we've got 4 times x minus 3. This is the factored version. 2x minus 1. And then finally, whatever we have in the denominator, how do we factor this right here? Difference of two squares, which ends up as 2x plus 1, 2x minus 1. All right, that's the hardest work there. What cancels?
2x plus 1. X minus 3.
So what are we left with?
4x minus 4 over x.
A lot of work, a lot of canceling there, but we still have to figure out what is it not allowed to equal. It's not allowed to equal this. It's not allowed to equal this. It's not allowed to equal that. It's not allowed to equal this. X plus 3 equals 0. That means x cannot equal negative 3. We've got x minus 3 equals 0. That means x is not allowed to equal positive 3. There's two answers. 2x plus 1 equals 0 would give us 2x is equal to negative 1, or x is equal to negative 1/2. That's what x is not allowed to equal. And then finally, 2x minus 1 equals 0. We get 2x is equal to 1, or x is equal to 1/2. There's another thing x is not allowed to equal, so we get 4 things. X is not allowed to equal positive or negative 3. X is not allowed to equal positive or negative 1/2. half. Yes, ma'am.
So, you also have to do the ones you cancel.
Yeah, just because it canceled out doesn't mean that, like, because if we put those numbers back in the original equation, we would still end up with a 0 there. So just because we canceled it doesn't mean you could ignore it. It just made we canceled them out to make the numbers smaller.